what if the real story of ancient Egypt isn't written in hieroglyphs, but in a potter's DNA? Let me take you on a journey back nearly 5,000 years when a potter was buried not with gold, but in a sealed clay pot. His bones have shattered centuries of uncertainty and just might rewrite what we thought we knew about ancient Egyptian ancestry. In 2025, a team led by Adeline Moraes-Jacobs, Joel Irish, and their colleagues sequenced the first whole genome from an ancient Egyptian, a man who lived around 2855 to 2570 BCE, bridging Egypt's early dynastic and Old Kingdom periods. His remains, discovered in the Nuweirat necropolis, 265 km south of Cairo and long preserved in a clay pot inside a rock-cut tomb, were kept safe even through World War II in Liverpool, enough that scientists could retrieve intact DNA from his teeth. This breakthrough matters because hot desert climates usually destroy DNA, but here it survived, and with it, the chance to unlock the genetic identity of pyramid builders for the first time. Radiocarbon dating places him around 4,800 years ago, making him one of the earliest Egyptians genetically profiled. The skeletal analysis revealed a man in his 60s, 5'3" approximately 160 centimeters, with advanced arthritis and bone wear pointing to a life of hard labor, perhaps as a potter, a craftsman, not a ruler. Yet he was buried in a unique way, suggesting higher social standing despite his presumed daily toil. So, what did the genome reveal? About 80% of his ancestry traced to North African Neolithic populations, especially from areas similar to ancient Morocco, suggesting indigenous roots. About 20% came from the Fertile Crescent, including Mesopotamia, marking the first direct genetic evidence of human migration or intermarriage between Egypt and Mesopotamia during this early era. He belonged to mitochondrial haplogroup I/N1, A1, B2, and Y chromosome haplogroup E1, B1, B2, B, both common in modern North African and West Asian populations. The team modeled he likely had brown hair, brown eyes, skin pigmentation from dark to black, common in North Africans, closest fitting modern Egyptian traits. This man was genetically closest to modern North Africans, especially Egyptians. But what truly caught researchers off guard was a significant signal of ancestry from southern Mesopotamia, a region that is now modern-day Iraq. In short, this individual wasn't a one-size-fits-all ancient Egyptian, as previously imagined. His genome suggests that Egypt, at least in this early period, was not genetically isolated, but connected by blood and movement to the Fertile Crescent, a cradle of civilization along the Tigris and Euphrates rivers. But what does that mean? Southern Mesopotamia was home to the Sumerians, a society famous for inventing writing, building city-states, and practicing complex religion and trade. Around 5,000 years ago, right before this individual died, Mesopotamia and Egypt were among the only civilizations on Earth developing urban, literate civilizations. Now, imagine this. The man buried in Nuweirat had ancestors who traveled, traded, or intermarried with families from southern Mesopotamia, possibly during a time of intensified contact between the two regions. Archaeological evidence already suggests trade in lapis lazuli, copper, ivory, and pottery between Egypt and Mesopotamia during this time. But this DNA adds something entirely new, biological evidence of people moving, not just artifacts, but bloodlines crossing continents, showing ancient mobility we could only guess at before. This archaeology news story also aligns with some growing archaeological theories that Egypt's state formation may have been influenced by contact with early Mesopotamian cities. Could this man have been the descendant of foreign traders, diplomats, migrant artisans? Or was Mesopotamian ancestry simply part of a larger, more complex population movement? We don't know exactly, but for the first time, we have genetic proof that ancient Egypt's foundation may not have been as insular as once believed. After decades of DNA failures, this is the first complete human genome from ancient Egypt. While turning rulers into mummies and burying them in stone tombs helped preserve their mummified remains, it turns out that it's not good for modern scientific methods. Hot, humid stone tombs destroy DNA. Thankfully, this potter was buried in a pot, helping out scientists trying to recover his genetic story. The authors emphasize one genome is not a population. More samples from Upper and Lower Egypt and from different time periods are needed to build a complete picture. There's also the race and identity debate. The way we classify race today is largely shaped by recent history, colonialism, migration, and politics, not by ancient genetics. People 5,000 years ago didn't think in terms of black, white, or Middle Eastern as we do now. Instead, ancient populations were fluid, constantly mixing, moving, and evolving across regions. So when scientists say this man had southern Mesopotamian ancestry, they're talking about genetic markers, not race, nationality, or identity in the modern sense. Genetic ancestry does not translate neatly into modern racial categories, something scholars and scientists caution against. But with this amazing archaeological discovery, we are hearing the genetic story of someone who lived through great events. The building of the step pyramid of Djoser, the rise of the Great Pyramid, but from a non-elite perspective.